With our playback experience optimized for the different types of content in our channel, we can now switch our focus from displaying and organizing content into monetizing it. Publishers can monetize content on the Roku platform through video ads, subscriptions, and one-time purchases. This lesson focuses on displaying video ads. We'll work on implementing subscriptions in the next one. Demand for free ad-supported streaming is growing, and the Roku platform includes a dedicated library called the Roku Advertising Framework, or RAF, that makes monetizing content with ads fast and easy. RAF provides a complete suite of client and server-side solutions for seamlessly inserting video and interactive ads into content. Video ads can be retrieved from your ad server, parsed, and rendered with just a few API calls. In this lesson, you'll learn about how RAF provides a consistent ad experience across the Roku platform, Roku's client and server-side solutions for inserting video and interactive ads into content, and how to get started with video ads. We'll then use Roku's client-side ad stitching solution to combine the content in our channel with video ads into a single playlist so the videos and the ads play back-to-back without any buffering. As we implement the solution, we'll discuss important requirements for displaying video ads on the Roku platform related to privacy, ad measurement, and child-directed content. The Roku Advertising Framework is a library in the Roku SDK that provides a set of built-in APIs for retrieving and rendering video and interactive ads. Roku channels displaying video ads must be integrated with RAF. This ensures that viewers can enjoy a consistent ad experience across the Roku platform. And for developers, this helps expedite the integration of ads into content, as RAF handles the rendering of standard messaging and feedback UI during ad breaks. RAF provides support for both client and server-side ad insertion solutions. RAF's built-in client-side ad insertion solutions, which work with Google Ad Manager, Freewheel, SpotX, and other third-party servers, minimize buffering between ads and content. For server-side, the RAF documentation includes samples demonstrating how to integrate with Verizon Media Services, Adobe, Brightcove, YoSpace, AWS Elemental, and Google DAI. RAF also provides support for interactive ads through Innovid, Brightline, and Roku. One of the key benefits of advertising on the Roku platform is measurability, and RAF provides a set of APIs that enable audience measurement through Nielsen DAR, DCR, and other platforms. To get started with your RAF integration, identify your first or third-party ad server. If you don't have an ad server, contact adsupport@roku.com for recommendations or alternative ad serving solutions. Read the video ads feature documentation for an overview of video ads on the Roku platform. Enroll in the Roku Partner Payouts program. In order to monetize ad-supported content, you need to provide a payout method and tax information. Read the certification requirements for ad-supported channels. These are important because your channel must meet all the requirements to be published to the Roku Channel Store. We'll cover many of these requirements as we integrate RAF in our channel. Finally, review the RAF integration guide and RAF API reference to learn more about implementing Roku's client and server-side ad insertion solutions. We're now going to use RAF's client-side ad stitching solution to insert ads into our content. This solution combines content and ads into a single playlist and then renders the playlist. This seamless creation and rendering of a stitched stream optimizes the video playback experience by eliminating buffering between content and ads. So the first thing we're going to do is clone the previous example. So let's copy the episode screen example, paste it, and rename it Video Ads. Now let's expand the Video Ads folder, expand the Components folder, and then create a new folder and name it Video Screen. This is where we're going to create our new video screen component that plays our stitched stream. As part of the client-side ad stitching solution, RAF creates its own video player node for managing the video playlist within the stitch stream and preventing the previously displayed detail screen from flickering into view between videos. When you develop your channel, you may want to use your own video player in order to provide a more customized playback experience. For example, you may want to design a branded custom trick play bar, which provides visual feedback when users seek, fast forward, and rewind content. In this case, you can implement the client-side ad insertion integration detailed in the RAF documentation. To create the video screen, open a new file in your text editor or IDE and create a component named Video Screen that extends the rectangle component. And we'll include a reference to the Roku SceneGraph XML schema. Next, let's add a script element that points to the corresponding video screen BrightScript file, which we'll create next. To create the interface for the video screen component, let's expose the video screen's content field, which is a node type, the start index field, which is an integer for storing the index of the selected item in the playlist. For this field, let's enable the always notify attribute so that the onIndexChange event handler is called when it gets updated. Let's continue by exposing the last index field, which is also an integer. It is used to show the detail screen once the video player is closed. Let's set its alias to the player task.lastIndex field. This exposes the video screen's last index field to its child player task component that we're going to create in the next step. And expose the isSeries flag, which is used to make sure that focus is set properly in the episode detail screen for series content. And finally, let's expose the close flag, which is used to indicate whether the video screen has been closed. Okay, the last step is to add a child element for the player task component, which is a task node that handles our RAF implementation. Let's set its ID to player task. Okay, we're done creating the video screen XML component. So let's save this file in the video screen folder and name it videoscreen.xml. Now let's create the BrightScript file for the video screen. So create a new file in your text editor or IDE and create an init function that uses the m.top reference variable to set the dimensions of the rectangle used for the video screen so that it's configured for HD. So we'll set its width to 1280. We'll set the height to 720 and the color to black. So then we'll get the video screen's child player task node using the m.top reference and find node method and stored in an m.player task component variable. This makes the player task accessible to the entire video screen component. And finally, let's create an observer to monitor the state field of the player task component. When all the videos in the playlist have been completed or playback is stopped, the state is updated and the onPlayer task state change handler is called to close the video screen. Next, let's create the onIndexChanged event handler. This method is called when a different video in the playlist is selected, which updates the start index field. When this happens, we want to get the content node currently at the top of the SceneGraph tree referenced by the m.top.content variable and set it to a content variable. The content variable contains a playlist with all the videos in the row of the currently selected item. We then use the event's getData method to get the index of the currently selected video and store it in an index variable. Now, let's add logic to verify that the content node has the metadata of the currently selected video. If so, let's set the player task's content node to the content variable and set its start index to the index variable. The player task now has the playlist and the first video in the list to start playing. Finally, let's set the player task's control attribute to run. This launches a new thread for getting ads and inserting them into the video to be played. The next method we'll create is the onPlayer task state change handler. As previously mentioned, this method is called to close the video screen after all the videos in the playlist have been completed or playback is stopped. So first, let's use the event's getData method to get the state of the player task. And let's add logic to check whether the player task's state field is either done because the playlist has been completed or is stopped because playback was stopped. If either of these are true, let's use the m.top.close field to set the video screen's close flag to true to indicate that the video screen should be closed. This triggers the onVideoScreenClose handler that we'll add to the video screen logic BrightScript file in a moment. This handler closes the video screen and returns to the applicable detail screen. The last method we need to create is the onKey event. This function closes the video screen when the back button on the remote control is pressed. As described in previous lessons, this method takes two parameters, the key that received input and a flag indicating whether it was pressed. As always, we'll set a flag named result to false, and we'll use this to track whether the video screen handled the back button key press. Now let's add logic for when there's a key press and it's from the back button and the player task node is still valid, to set the control attribute of the player task node to stop. This triggers the onPlayerTask state change handler we just created to close the video screen. Finally, let's set the result flag to true and return it to let the Roku OS know that the video screen component handled the remote control key event. Great, the file is done, so let's save it in the video screen directory and name it videoscreen.brs. We're going to handle the RAF implementation on our channel next, but before we can do that, we need to update our channel manifest by setting the BrightScript library's required attribute to the RAF library, which is denoted as Roku Ads. So in the root video ads folder, let's open the manifest file and enable this attribute. This lets the Roku OS know that our channel requires the RAF library. And that's it. Let's save the manifest. And okay, so the next step is to create a player task component that handles our RAF implementation. To create the player task, open a new file in your text editor or IDE and create a component named player task that extends the task component. To create the interface for the player task component, let's expose the player task's content field, which is a node type, and then expose the start index field, which is an integer for storing the index of the selected item in the playlist. And finally, expose the last index field, which is also an integer. It is used to show the detail screen once the video player is closed. Okay, the last step is to add a script element that points to the corresponding player task BrightScript file that we'll create next. Let's save this file in the task folder and name it playertask.xml. Now let's create the BrightScript file for the player task. So create a new file in your text editor or IDE and insert the RAF library in this component. The RAF library only needs to be included in tasks that directly handle the RAF integration. Now let's create an init function that sets the play content with ads function, which we'll create next, as the function that will be executed when the state of the player task changes to run. And let's expose the player task node to the rest of the channel application. Okay, now let's create the play content with ads function, which handles the RAF implementation for our channel. In this method, we'll instantiate the RAF library, configure and enable ad measurement, enter the URL of the ad server where we'll retrieve our ads, combine the currently selected content with the ads we retrieved into a single stitch stream, and then render the stream. First, let's get the video screen by calling the ROSJ node's m.top.getParent method and storing the video screen in a parent node variable. This is the screen that will attach to our stitch stream. And get the content node currently at the top of the SceneGraph tree referenced by the m.top.content variable and set it to a content variable. The content variable contains a playlist with all the videos in the row of the currently selected item. Let's get the index of the currently selected content in the playlist, which is stored in the m.top.startIndex variable, and set it to the m.topLastIndex variable. This line of code assumes that the last video played was the one that was originally selected. We'll use the m.top.lastIndex variable to display the appropriate detail screen once the video screen is closed. Now let's use the ROSJ node's getChildren method to get all the child content nodes for the video stored in the content variable's playlist. To get all the child nodes, we'll pass -1 as the number of nodes to be retrieved and the 0 index in the playlist as the starting position. Now let's instantiate the RAF interface. We do this by calling the Roku Ads constructor and storing it in an object reference variable that we'll name RAF. This object manages ad server requests, parses ad structure, schedules and renders ads, and triggers tracking beacons. And now let's enable audience measurement. This is required for channels displaying ads. It enables audience identifiers to be passed in the impression tags that will be sent to your ad server. Now let's set the URL of our ad server. For this example, I'm going to leave the ad server URL parameter empty in order to use Roku's default URL for development and testing. When you integrate RAF in your channel, you will pass the URL of your third-party ad server and insert macros in the query string for the user's Roku ID for advertising, or RIDA, and the limit ad tracking status, or LAT flag. The RIDA and LAT flag must be passed in every ad server request. And now let's set a flag named keep play to track whether the playlist has been completed. And get the start index of the selected item in the playlist and subtract 1 and store it in an index variable. Get the number of videos in the item playlist using its count method and store it in an items count variable. Now while the keep play flag is true, let's make sure the playlist hasn't been completed. To do this, verify that the number of videos in the playlist is greater than the index of the currently selected video, -1. And if so, set the focus to the video screen by enabling the setFocus method on the parent node variable. Then we'll increment the index variable, and then get the content node for the video to be played next. We do this by getting the index of the video from the items playlist and storing it in an item variable. Now we'll set the content metadata items that are required for audience measurement. This includes the video's ID, genre, and length. These values must all be passed into the appropriate RAF APIs in order for your channel to be published. First, we'll set the RAF object's content ID to the ID of the video to be played next. This ID is specified in the content feed. It's important to note that if you plan on developing a channel with child-directed content, you must also pass a kids content flag that is set to true in the setContentGenre method. This is required for serving ads during child-directed content. Next, we'll pass the video genre. For this example, we'll use the movie, short form, or series categories in our content feed. So let's first verify that the video's category is valid, and then set the RAF object's content genre to the movie, short form, or series category. The genre tags that you must provide depend on your ad server. So check with your ad server first for the correct tags to be passed before configuring this method. The resources section includes a link to the list of valid genres that may be passed to RAF for proper audience measurement. Finally, we'll set the RAF object's content length to the duration of the video. With our audience measurement metadata set, we can now call RAF's getAds method to retrieve the ads to be played during the next video from our ad server. This method returns the full list of ad pods parsed by RAF from the ad server response. We'll store these ad pods in an ad pods variable. And we'll store the index of the last video played in the m.top.last index variable. As previously mentioned, we'll use this variable to display the appropriate detail screen once the video screen is closed. So now that we have the video to be played next and the ads to be shown during its playback, we can combine them into a single playlist using the construct stitched stream method. This method takes the video's content node and the ad pods and returns a single stitch stream that will store in a CSAS stream variable. And now we'll render our stitch stream by passing the CSAS stream variable and the parent node variable, which represents the video screen, into RAF's render stitch stream method. This method takes the stitch stream to be rendered and the view or screen the RAF messaging UI is to be attached, and returns a boolean indicating whether the stream has been completed. We'll update our keep play flag based on the results of this method. Finally, we'll add logic to toggle the keep play flag to false in case the number of videos in the playlist is not greater than the index of the currently selected video, -1. This indicates that all the videos in the playlist have been completed. Great, we're done with this method and we're done with the file. So let's save it in the tasks folder and name it playertask.brs. Okay, we've got one last step before our channel is complete. We need to update the video player logic BrightScript file because we replaced the video node used in previous lessons for playing content with a video screen node we just created for this one. So let's open the video player logic BrightScript file, which is located in the components UI logic folder. So the changes we need to make are fairly widespread. We're going to overhaul the show video screen method and replace the on video player state change method. So let's start with the show video screen update. Let's delete all the existing business logic in this method. First, let's create a new video screen object and store it in a video screen reference variable, and then create an observer to monitor the close field of the player task node. When all the videos in the playlist have been completed, or playback is stopped, the close field is updated and the onVideoScreenClose handler is called to close the video screen. Now let's configure the content to be played on the video screen based on the parameters passed into this method. Let's set the video screen's isSeries flag based on the isSeries parameter. Set the video screen's content node to the row content parameter, which represents the row of content containing the selected video. And then select the video screen start index to the selected item parameter, which represents the index of the currently selected video. Finally, let's pass the video screen into the showScreen method to add the video screen to the screen stack and then display it. Now let's replace the onVideoPlayerStateChange and onVideoVisibleChange methods with the onVideoScreenClosed handler. This method takes an event, and we'll use the event's getROSJ method, which will return the video screen component. We'll store this in a variable named VideoScreen. And then we'll use the event's getData method to get the current state of the close field. If close is set to true, we'll pass the video screen into the closeScreen method to remove it from the screen stack and close it. We'll then call the getCurrentScreen method, which will return the applicable content or episode detail screen. We'll store this in a screen variable. Then we'll switch focus back to the detail screen returned by the setFocus method, and if the isSeries flag, which was passed into the showVideoScreen method, is set to false, we'll set the detail screen's jump to item field to the video screen's last index field. This sets the focus in the detail screen for movies and short-form videos to the last video played. For the episode's detail screen, focus will be set to the episode selected in the episode screen. Okay, we're all done updating this file. Let's save it, and our channel is now ready for displaying ads. Great, so now let's test the channel on your Roku device by sideloading it. So let's archive the content in the Video Ads folder and use the Development Application Installer to load it. You can see that now when we launch a video, a pre-roll ad pod is displayed. The RAF messaging and feedback UI displays the ad load in the upper left-hand corner of the video screen. When we press the back button on the Roku remote control, the video screen is closed and the detail screen opens. Let's pick another video to demonstrate a couple of other certification requirements related to the playback of ad breaks. First off, ads cannot be fast-forwarded or rewound. Therefore, fast-forward and rewind button presses and voice commands are ignored. Also, pressing the back button during an ad break and resuming playback cannot skip the ad break. When the video resumes, an ad break must be initiated to preserve the previously exited ad experience.
Thank you so much for watching this video. For more Roku developer videos, subscribe to our channel. And for the rest of the videos in this course, as well as additional demos and tutorials showing you how to develop on one of the world's leading streaming platforms, check out the link to the Roku Developers video site in the description below.